Good morning to all. In the previous session, you must have gone through the presentations connected to the distribution law, Nernst distribution law. I would like to recall this is what the Nernst distribution law. It says that if a solute X distributes itself between two immiscible solvents A and B at constant temperature, and X is in the same molecular condition in both the solvents, that is the if clause, we should not forget it, then there will be a ratio between the concentration of X in the solvent A and to the concentration of X in the solvent B. That definitely will be a constant. That constant is called Kd. You can even express it like this. If C1 denote the concentration of the solute in solvent A and C2 the concentration in solvent B, then the Nernst distribution law can be expressed as C1 by C2 is equal to Kd. The constant Kd, or simply K, is called distribution coefficient or partition coefficient, or it could be distribution ratio. We identify the constant by using these three terms. Today, we are going to discuss what are the applications of this distribution law. First one is solvent extraction. Solvent extraction you have already learned in your first semester. Solvent extraction is a technique by which we separate the component of a mixture. So the idea behind this is, suppose if you have two components, best example it is salt and sugar. If both are mixed, how do you separate it? We know that the sugar, it is an organic compound, and the salt, it is an inorganic compound. It is composed of ions. So if you recall the slogan, that is like dissolves in like, that means every organic substance will have more affinity to get dissolved in an organic solvent, and every ionic compound will have more affinity towards the polar solvent to get dissolved. This is what the concept behind this. This is more or less connected to the chromatographic technique. The affinity is important. So suppose if you get a mixture of sugar and salt, what you need to do is, you need to take a separating funnel. So initially what you will do is, you will be taking the you will be taking the sugar and the salt, which is in the form of mixture, and dissolving into this aqueous solution. Now it is completely dissolved in aqueous layer. Then you know that the sugar is an organic compound. Then into that, this setup is called what we call a separating funnel, and into the separating funnel you will be adding a little of organic layer. Organic layer means it is made out of an organic solvent. It could be acetone, it could be ethyl acetate, it could be there are many organic solvents. So generally we take ether. So why do we take ether? It is once you extract the organic substance into the ether layer, the evaporation of the ether is easy because the ether is having very low boiling point. It is highly volatile. So you will be adding 50 ml of the a particular quantity of the ether into the solution. So you have already added here. So what will happen is you will be shaking that very well, and you will see that the maximum amount of the sugar has got dispersed or distributed into the organic layer. And what you will do is you will elute it. Elute it means you will take it out. So you can open this knob and you can take out the solvent which is there at the bottom level. So you will be taking out the water. So distribution means, recall that the distribution law says that it need not, like if you have mixed it like 50 ml, need not be that the whole amount of the sugar need not be getting into the organic layer. Some maximum, some part of, according to the distribution ratio, some part of the sugar will be getting into the organic layer. So you will be repeating the procedure. So for that you will be taking out the layer, the aqueous layer, and into the aqueous layer again you will be adding this organic solvent, so that if some amount, like it depends on the ratio. Initially there was 100 molecules, then what will happen is around somewhere, let us guess, it's a rough guess, so around 60 40, now 40 is remained in the aqueous layer. So from that 40 with the same ratio, you could see this is 3:2 ratio. So from 40, 3:2 ratio. So what is the 3 part of 40? So that will be, if you take 5, 8, so 5 into 8, around it will become, the ratio will become 24:16, like that. So next, if you do once more, the 3:2 ratio will be followed, and maximum more and more amount of the sugar will be getting into the aqueous layer. So you repeat the procedure, and finally you will get an aqueous solution which has very, very minimum amount of sugar. Most of the sugar will be getting into the organic layer. This is what the technique. So separation funnel, you need to have a separation funnel. You need to have two different solvents, an organic solvent and aqueous layer. So the same method is what we use for extraction of the alkaloids from the plants. So the alkaloids are soluble in organic layers only, most of the alkaloids, and they are water insoluble. So to extract the alkaloids, there is a branch of the research is what we call phytochemistry. In phytochemistry, we collect the leaves and we dry it, and according to the polarity of the solvent, alkaloids could be extracted. This is what the technique what we use for extracting the alkaloids from the leaves. This is Fazal, Assistant Professor, Department of Chemistry, Sir Syed College.